Hey everybody, this is Larry. This is me still catching up on the Leetcode Weekly Contest. I am up to weekly contest for 77, I think. If not, then I'll just have to record the intro. But if you're watching this, then I am doing that. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about this farm, this contest, everything in between. And yeah, let's go. Let's catch up. Go, 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 go. Do. X times so. What? Okay. I don't know. It's so weird, but okay, fine. Something like that. So weird. No, I was thinking about it just as I was fighting. I was like, wait, do I have to worry about 0? Oh no. Okay. Fail. Oh well. The longest subway that's a bitwise XOR of 0. And 10 canes, you go. Okay. Huh, that's fun. Yeah, I mean, I think that's just prefix somewhere. Longest, wait, so okay. Oh wait, is this? Oh no. This is a medium? That's kind of hard for a medium, I think. Maybe not. Right, so... Okay. Wait, 0. Okay, 0 is not what I expected, but Am I summing up? Why is this so weird? Why is Delta so hard? 3 odd 1 year. What am I? Something is a little bit off. This one should match this one, right? So why is it not? Oh, I did it the other way around. Whoops. That's a bad typo. It's fine. 480, right? Okay, no silly mistake this time, which is nice. This is the same as part 1. Can't even type the mod correctly. Okay. X. Huh. How many queries do we get? A lot of queries. Is it really just all prefix sum? Probably. We have a prefix sum on what? On the actual sum. Okay, fine. That one is easy. Right, and then you have another one on the shift and add. The other one. No, 2 loops is fine. No, we have to fix this though. And then that's the sum, right? And then you have the digits. That's not right. 1 3. What is 1 3? 1 3 is give me 2. Oh no, wait. This is just because. Wait, what? No, let's see. That's weird, actually. 1 1 1. So the sum is 3, which is fine, and this is 1 1 1. Why is it 1 1 1? Or even this. Wait, it's 1. Oh, I think I shifted the wrong way. No, that's right. but the subtraction is wrong, I think, because then now it is almost in reverse because we want No, it's kind of right. It should be, in theory, it should be 12 minus. No, that's how you get 11, but Okay, so maybe the way I was doing it is optimistic and wrong. Okay, I mean the prefix sum part is easy, but the real string part, because I was hoping that it would be, and this doesn't even make sense anyway. It should be the other way around. If anything, no, it's not the other way around. But then, okay, so this would give me 12, and this would maybe give me, well, this would give me 1. So that's how you get it. You have 12 minus 1, but that doesn't even make sense, right? So what you want is 12 minus 1, but with the shift. So it should be 12 minus 10 to get rid of the prefix, because the suffix is all the numbers, and then okay, so then there's a number of non-zero numbers. That's the shift you have to do, right? So this is this times somewhere like number of digit shifts something like that, right? And then C, you have to calculate C is equal to prefix. Right, and I'm going to do another one. Okay, I mean that's not quite right. Oh, it's number of zeros. We want the reverse of that, right? The number of non-zeros. Oops. Okay. Okay. 910. Okay, looks okay. I mean, am I confident? Honestly, not really, but good enough for me to YOLO because it matches, I think. Okay. Did I open the same problem twice? Okay, there we go. Wait, I did do the other one, right? Like I didn't. I don't know. Okay, I just clicked on the same thing twice. All right. Now with 17. All right, let's go. Number of in the renown the string or its elements. Another mod. Number of defective. The strength is the bitwise OR of all its elements. Okay. A subsequence is conceived when that subsequence strictly decrease the string with the remaining elements. What is remaining elements? Let's go. Let's see. Oh, it's an OR, not XOR. Okay. Well, I mean, we have to think about what that means. Okay. I don't know what this means. Can someone speak English to me? Oh, I see. So you remove 1 and 3, 2 becomes lower. And strength is, I see. Okay, so it's all the elements, not all the. It's very tough when they mix arrays and subarrays and all these things. Okay. And n is big. I think it's easier to count the number of things where we don't remove. Well, removing it doesn't change anything, right? Was it again 10 to the... Oh, it was only 10 to 6. So that means there's only 20 numbers. So maybe it's a bitmask DP type thing. Index and bitmask could be too much though. It's subsequent, so you can do the logic or whatever they call it. I don't remember. All right, let's see. So what is? But actually, what I said doesn't even make sense. Because if there's like 2 7s, for example, like this. Oh wait, no. The end is always at least 1. Thanks, Larry. It's what's it called? Inclusion exclusion on the bits. Is that even right? Remove all numbers of 1 bit and then 2 bits and then just add it back in, something like that. That's a lot though. I mean, well, it's not if you do it intelligently. I don't know that I am doing it intelligently. For each number, if you look at all the bit possibilities, that's too much, right? How do you do the count? If we could do the count, then I think that's fine. For inclusion exclusion out? I think my skin is too dry. I keep on rubbing myself. Inclusion exclusion probably makes sense for bits, but how do I count them? Because building that for each number is the tricky part, right? For each of the subsets of the inclusion exclusion. Am I doing it right? 10 to the 4. What's 10 to the 6 again? 10 to the 6 is a million, right? Okay, I just want to make sure that. Yeah, no, that's 20. 20 is big, okay. What? How do Peel? Oh, Peel got it fast. What happened to the like really smart people? I feel like I don't see the ridiculous people on top anymore, because you know somehow everyone got smarter with the power of AI. I'm still trying to get inclusion exclusion to work in my mind. I just don't know how to count them in an easy way. Or a fast enough way, rather. I mean, it's easy, but it's a 10 to the 5th times 20. No, I don't think you could do it that way, Larry. And is that really right, inclusion exclusion? Because you get in this one, for example, 7, 6. I don't know that I know how to do this one, huh? We have an hour. How do you do it without? Okay, let's think DP maybe. I don't know. DP is bitmask DP. What are you doing with bitmask DP? Without inclusion exclusion, I don't know how to be precise, but that's too slow unless I'm missing an angle on how to calculate it. I could pre-build it maybe. Prefix sum, because okay, what does it mean? Let's say we have numbers 6, 4, and 2, so then that's just we just put bit 2 and 3, or 1 and 2 depending. Okay, so you have 2 bits, and then you combine the 2 bits. You have to do that for every number, right? Like, how am I doing that? I don't get it. I might get the idea, but I don't know how to do it fast. Is there a way I can do it with like a Civ-like idea? Can I do 1 bit at a time? No, because you have to still look for the numbers, right? The problem is the power set of x is x, right? Which is too much. We have to do it for each number. I need a different idea. That's not working. It is the idea that one of the bits has to go to 0, and then 2 of the bits has to go to 0, subtracting out whatever, and that's inclusion exclusion. Can I work on it backwards? And backwards is still the same thing, at least the way that I'm thinking about it. So you work from 0. Is it like a breadth-first search idea? No, I mean, because the shortest path type thing doesn't really help, right? It's just, it's a count. Like even the minimal set or something like that, which is NP anyway. But let's say we have that solution, it still doesn't give us the count of the other ones because you don't need the minimal set. I'm gonna use the rest of them real quick. Don't really have any ideas though. Also, my kitchen is, as I mentioned, sometimes kind of cold, so I'm for my small heater to warm me up. I think that's why I need to use the restroom all the time. It's just cold. I mean, the other way is how do you get, maybe that's the easier way, is the number of subsequence that that lets you get to the max. But that's not very, because the intuitive way would be like maybe, I don't know, like the index and then the bit mask, but that's gonna be too slow for sure, right? Because n is like 1,000,000, this is 1,000,000. Especially when you do tick no tick. Yeah, right. Well, let's see. Right, index n. I really have no ideas. I'm just kind of writing code to maybe like give me some ideas. We get to the end. Then we just return 1, maybe return 0. Otherwise, I don't know where I'm supposed. And just tick no tick, maybe. But that's definitely gonna be too slow. Or out of memory or something, it doesn't really matter. Right? Is this good? It went fast. I think this is the opposite of what we want, which is fine, which is easy fix. Right? But this is, like I said, it's gonna be too slow. I mean, this is way easier, right? If it was subaway, you can maybe use a control log trick, but because this is subsequence, I don't think you could do it that way. Yeah, given 1,000, maybe too slow. Oh, actually, it's fast enough. It's actually a little bit too fast. Yeah, I mean, you know. So, once you get to 10 to the 5th, it's gonna be no bueno. What am I missing? Divide and conquer? Is there good divide and conquer? I don't think so, but... Well, I wrote something, but it didn't really help. Is this the one base? What's it called? One basis thing? No, that's an XOR basis, right? That's XOR, that's not OR. But is there something like that where I can do no, getting you the dimension is not going to get it. No, I mean I don't think so. Not the count. Like I said, that would maybe give you the minimal number of numbers for it or something. But that's not what this one asks. And anyway, is that true? No, well, no. Can't really do one bit at a time because otherwise, I mean, that's why you need the inclusion exclusion. Mm. Yeah, I don't know. I mean, there are a lot of like, I don't know. I mean, I don't know. Because I did it very quickly. I have no idea. I mean, all my ideas are kind of like with inclusion, exclusion. 40 minutes. Do I just YOLO? That doesn't look like. I don't know. Yeah. Alright, how would I do it? Nope. Something like that. That is easy to write. I should remember that. That's it, right? The other way around. Something like that. I don't remember how it goes. Okay, now inclusion exclusion is just I don't know, something like this maybe. I think I'm missing something. Or the other way around, I never know. I should probably save this or whatever. I don't usually write it this way, right? Isn't it a bit count? And it's not. Also, I mixed up stuff. Actually, it's just bit count, right? So just. Something like that? Does that even work? Nope. What am I missing? I don't remember how to do some of this stuff anymore, honestly. So there's one number with 1, 2, and then put 3. Is that right? For 1 and 2, the 3 ways to do it. I mean, that's quite right. This is a little bit off, isn't it? Is it the other way? Am I mixing them up? Okay, it's one right? One is definitely not right. No, it's 1 we had, right? Maybe? I don't know. Shouldn't matter, really. Oh, what the? Oh, I guess this is negative then. Because I'm doing it wrong. Okay. Answer is 3. What does this 3 mean? This 3 means that there's 3 numbers with either one of those bits, right? Do I have to pick all of them? Is that it? Oh, I guess we have to pick all of them then, right? So that means that, okay, if that means that if there's one number here, then the opposite of that, or all the other numbers, it's going to be the power of, so it's this, what is it, n minus this? N minus this, and then the power of 2, right? Something like that, maybe? Alright, maybe I... Yeah, okay, I mean, I don't know. But basically this is saying that, okay, if we take away all the numbers of this one bit, that's not even true though, right? I feel like this, something was wrong. Maybe I meant this the other way. Did I do this loop wrong? Was 1, 1 goes to, so this used to be a 1. It used to be a 1, it goes down, right? This one looks right, but man, I do not remember how to do the sequence stuff. Because you remove all the ones, but that's not enough, right? Because you also want to remove all the 11s. Am I doing it well? Well, we're keeping all the ones. What am I doing? I'm writing it wrong. 6 I could do the same actually, which is kind of funny. That's not what I want though. This is kind of what I want, but the answer doesn't, or the thing doesn't really make sense. All 3 numbers is a superset of 0. 2 numbers have 1, 2 numbers have 2, only 1 has both, which is kind of what I want, right? And what does that mean? Okay, so that means that when we're at 3, that doesn't really do anything, right? Do I do zeros at all? It's probably not. I don't know. Maybe that messes things up here. Okay. Because now we have 2, we have to remove both 2 of them, right? Is that what I'm saying? Or keep 2 of them, or keep 1 of them? No, we want to remove both of 2 of them. If we remove 2 of them, and what does that mean? That means all the other ones are, yeah, possibly, doesn't matter, right? So, which is only one possibility, so it's either keep or no keep. Do the 2 good things, right? This as well. That should give me 4 maybe. Why is this working? This one doesn't give, it's fine because it's subtracting, right? What am I doing wrong here? Man, I really don't remember this. Basically it takes it in, okay. What did I do? What did I change again? Why are these numbers so crazy now? Okay, so that means that there's only one number that's good. No, that's not true. One sequence? No, that doesn't even make sense. If you have 3, then you're good, right? You have to remove the 3. Or actually, okay, let's look at this. It's just dreamy. Maybe I just don't remember how to, maybe I'm missing a component. It's not, I'm not gonna lie. You remove this one, it doesn't get rid of it. Right? So then what are we doing here? Oh. What am I missing? What am I missing? And he just gives it a 1 for no reason for these zeros. Man, maybe I'm just having a rough day. Okay. What is, trying to understand this first, right? So this means that this one number that only has it in the 1 slot, only has it in 2 slot. 3 numbers that have it on either one of those. So we're going to get rid of all the, okay, so I have to keep one of these. I don't know, what's going on? I mean, I forget how this goes, but this should be right. Unless I'm like missing a 1 or something, but I mean, oh well. It's one or the other, anyway. I'm trying, I mean, I don't know, I could just look it up, but I'm just trying to think through what the interpretation and from first principles. I mean, solving at this contest doesn't really matter to me per se. So idea here is that remove a 3. Well, you can't just remove a 3, right? So you have to remove another one. But how does that come out? Okay, let's take the bit mask. This is so we're trying to get the count. Okay, so let's say there's 3 numbers that have either one of those things. So no good. Okay, so you have one number that has a 1. So you keep the 1, or you want to get rid of all the other ones? That's the part I'm confused about. Oops. What? How does that even? Okay. I mean, I don't know how this works. Well, I mean, we didn't get it right, but it. Wait, why does example 3 have? Oh, because that's a lot of bits. A lot of those bits don't matter, so maybe I just have to get rid of them or something. Like, okay, let's just try something like 1 1 for sake. Okay, but why does this work? I guess I do have to kind of get rid of the extra bits. I guess this makes. I guess B, we cannot use B for that reason. Oh, because we. Okay, well, how did I even get the right answer? I mean, this isn't right yet. I have to do some stuff, but not very happy with this. No, because this loop. Well, maybe this loop too. How do I do it? Just get rid of the bits that don't matter. Is that it? Okay, fine. How do I want to do it? Nope. Yeah, whatever. I think it's just like 20, but whatever. Is that good enough? I don't think complexity was going to be too slow, to be honest, but maybe I'm wrong with that one. No, it's not max anymore, right? It is... probably have to cache that. Okay. I'm just gonna YOLO submit. I don't care anymore. We have 17 minutes. We'll see. We'll see if I get a wrong answer. Huh. I don't know what to make of that. I didn't think this would be faster. Well. Honestly, not quite sure how. I mean, I'm interpreting it a little bit weird, and just kind of finagle it. I mean, this is just inclusion, exclusion. What am I doing? I feel like I have no idea how. Sometimes. I guess this cleans it up, that's why. But you know, these are real zeros. But wait, are they? Two. This is kind of weird, actually. For two. Oh no, this is a one. I mean, this is just a standard, what's it called? Subset over, what's it called? I don't use it. Sum over subset, that's the idea of it. But this one is pretty straightforward, but I guess I was thinking about when I was constructing my in my head anyway, because I didn't code it out. I was thinking about it the other way of, okay, you have, for example, you have a 3 which has 2 1 bits, then we would have to throw out 1, 2, and 3. Right. I guess what I'm doing is doing the opposite, which makes it slightly easier. Which is what this is for. I guess that's why I did it. Because if I had filled out the other way, it would be too slow. No, I don't know. Why is it wrong? I actually kind of want to do it the other way with maybe something like this. I mean, that's what we had earlier, right? And now we don't have to do this, right? Maybe I was just mucking up because of the where we have to 0. Maybe this is a little bit messed up now. Well, maybe not. Because the idea here is that on the inclusion exclusion, if we get rid of all the 2's, I was trying to work on this. I don't know why I'm getting. or the 1 digits and the 2 digits. So you want to get rid of all of these, and there are n minus np way of doing it, right? I don't know why this doesn't work. So now this is saying that, okay, there's 2 ways of doing it, of getting rid of at least these 2, and 2 ways to get rid of these. I guess this is where it fails, because then now the exclusion part is not, it should be 1 way of doing it, so it's not n minus dp. I don't know, I gotta review my notes, my homework, I think. Possibly, probably. Also, I hit my head or something. My head hurts, like physically, not. It's kind of weird. Maybe I do need to review my notes. I mean, this is fine, right? This is just a dp over sum. But I don't know why my inclusion exclusion map is so bad. Is this saying that we're keeping this? We're keeping the 1, but there should be more than 1, right? We're keeping at least 1 bit. So we're getting rid of everything else? That doesn't make sense. Well, this is the complementary of that. So this actually goes to this. So it is saying that we're getting rid of, we're keeping all the other ones, but I see. And you have to keep 1 number to keep, you have to keep 1 number. I don't know. Okay, for example, this is 3. That means that you have to keep 0 of them. So there's 1 way, which is this way. There's 2 ways. Okay, this is saying that there are 2 ways to keep them, which is true. 1, 2. This is also 1, 2, and then the 3 is subtracting out the overlap. I don't know. I need to study some stuff. I don't know. I also, I guess the way that I originally constructed would have been too slow. But anyway, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.